Alright, we wrap up this exercise with something on the properties of cross product. Let's review something about cross product. Suppose we have a vector A, a vector B in space, alright, 3D, right, space, and they animate from the same point. And if we perform the cross product of these two vectors, you get another vector W, and this vector W is would be perpendicular to both A and B. Okay, remember, remember this is going to be a vector that is perpendicular to the A and B. There is a possibility, and it's very probable, of course, that W is going the other direction. So when that occurs, we will write negative W, but this negative W is still perpendicular to A and B. Okay, as a result of this, there is a few properties, very interesting properties. And the first one would be that if you cross product the same vector by itself, you get a zero vector, and means in which all its components are 0, 0, 0. And the other property would be that if you then do this A cross B, because of this idea where W, the resulting vector, could be pointing this direction or the other direction, so A cross B is equal to negative B cross A if you switch the order. When you perform cross product, the order where you put what vector you put first is very important. And so when you switch the order, you have to add the negative in front. And there's one more property that is this: if we have A cross the sum of two vectors, the outcome is actually A cross B. So it's something like expanding, right? A cross C, so expanding this. And the last one, but last but not least, we have A plus B cross product C plus D. The outcome is something like expanding again, something like A and C. So you have A cross C, B cross C, plus B cross C, plus A cross D, and B cross D, right? And so we'll look at part A. It is question 11. Now A cross A plus B, if you think about it, this is although these two vectors are the same, but it is very, in terms of its forms, are very similar to this property 3. You can use property 3 to help us, and so that means if we look at it that way, this is equivalent to A cross A plus A cross B. So because recall that in this property 3 is as if you're expanding the vector, you know? And so A cross A, right here we know that it's actually the vector 0. So vector 0 plus A cross B. And so if you simplify this, you get A cross B, right? I'm going to do a little bit of C, just start the part C, but not finishing it, not really. Start from the given expression, and if you think about it, this is actually basically there's the property 4, where 2A is your A and B is the same as the B here, and cross C plus D. but now the C is A, the D is negative 2B. Okay, so if you think about it, it's kind of like expanding the binomial. So 2A cross A plus B cross A minus 2B, or should I say 4A cross B, and minus 2B cross B. Okay, if you continue with your work, you would find that, okay, leave this exciting part to you. You perform this, you will eventually get 5 times B cross A, right? So you should have fun doing this. And next one, right here, we'll go to next questions. 12. You find all vectors perpendicular to both vectors given. I just want to do A, but recall again, if you have two vector A, B, you find its cross product, you get W, and W is perpendicular to A, and W is perpendicular to B also. And so what we're going to do is that we just cross this, because we know the outcome of this product is a vector that's perpendicular to both of them, right? So arrange them nicely. I, J, K, negative 2, negative 1, 3, 1, 1, 1. I copy the first column, I, 2, 1, and second column, J, negative 1, 1. Perform this, this, and this, and then I will get negative I, right, plus 3J, and plus 2K, right, brackets. And now I do from bottom to top. I'll get negative K plus 3I and plus 2J. And check this, then we have minus 4I and plus J and plus 3K. And so the vector we're talking about is negative 4, 1, and 3. However, recall that there is another vector which is also perpendicular but is going in the opposite direction. So then that other vector is the negative of W. And so although this is indeed one of the vector that is perpendicular to both vectors, these two vectors, but there is another one, and that vector is the negative of your answer, or in other words 4, negative 1, negative 3. So these two vectors are both perpendicular to the vector 2, negative 1, 3, and 1, 1, 1. I hope you try the other questions, and good luck, and all the best.